Evaluate the following limits if they exist. In part A, we got this function when x approaches to 1/2. So cosine function, here is an exponential function. All we have to do is plug in x equals 1/2. So that is then cosine of pi times 1/2. That is pi over 2 minus e raised to 1/2. Okay, 1/2 for x, 1/2 minus 1/2, 0. Cosine pi over 2, we know that that value is 0. Cosine 0 is 1, cosine pi over 2 is 0, minus e raised to 0 is 1. Any number raised to 0 is 1, so 0 minus 1 is -1. Final. In part B, if we plug in x equals -1, on the bottom we are getting 0, on the top -1 is square, +1 plus 1, 2 minus 2 is 0. So we get 0 over 0. That means we get a removable discontinuity at this. So we need to do some more work before we plug in this. So we factor the top and bottom and cancel out the 0 making factor. On the bottom it's easier, just pull 7 out, x plus 1. On the top, this is a trinomial, so if it factors is a product of two binomials, so x is square here, so x is square means x times x, and 2 means 2 times 1, 2. To get negative in the middle, negative goes to the bigger, plus to the smaller, and obviously x plus 1, we have to have x plus 1. Now we can cancel, and all we have to do is now plug in x equals -1. So -1 here, -1 minus 2, that's -3 over 7, and that is same as negative in the front, -3/7. Okay, so part C, we got a square root. If we plug in h equals 0, we get root 16, 4 minus 4, 0 over 0. And we know that whenever we have radical sign involved, we multiply by its conjugate. So that's 16 plus h. This negative is just +4, and same thing on the bottom. Okay, that is now limit h going to 0. There was no issue on the bottom, so just write h times this quantity, 16 plus 8 plus 4. On the top we FOIL, you just multiply this times this first, okay, outer, then inner, and last. Okay, so when we multiply this root 16 plus h with root 16 plus h, they are same, so we get root 16 plus h quantity is square, and square and square root cancel, just 16 plus h. And when we multiply this with 4, so 4 of this, and inner -4 of this, same thing, so cancel, so middle two terms cancel. You can FOIL out and cancel middle two terms, and -4 times 4, -16. Okay, and let's simplify the top. On the top, this is +16 minus 16, that's 0. So that leaves h over this, and we can cancel this h and h from top and bottom, so that's just 1. So basically we are dividing. 16 minus 16 is 0, but top after 16 is gone, then just h left, so we are dividing, so 1, 1. Okay, so 1 over this. Now we are able to plug in h equals 0, so that is 1 over root 16 plus 0, 16. Root 16 is 4 plus 4, 8. So 1/8 is the answer. In part D, we have a complex fraction on the top, so let me combine these two over here, somewhere here. 1 over x plus 4 minus 1 over 4. So to add or subtract two fractions, we have to make common denominator. For we multiply first fraction by 4 over 4, second by x plus 4 over same thing. Now we have the same denominator, 4 times quantity x plus 4, 4 times 1 4 minus, okay, be careful, minus. Now we need to distribute negative 1x, negative 1 times 4, negative 4, and on the top this positive 4 minus 4, that's 0. So if we come back here, when we combine these two fractions, we're going to get negative x over this 4x plus 4. Now we still have a complex fraction, so this is the top and this is the bottom. This is the original, okay. So when we have a fraction, we keep this, change and flip. The x on the bottom is same as x over 1. Okay, so we keep the top, okay, change this division into multiplication and flip. So let me do that over here. So we got limit x going to 0, negative x. This on the top can be pulled to the front, negative x over 4 x plus 4. Change this division into multiplication. Now flip this fraction, 1 over x. Then x on the top, x on the bottom cancel, just 1. So 1 times 1, 1 on the top. So we are not getting 0 over 0. So just simply plug in now. Negative in the front, just 1 left on the top, over this x is now 0. So 0 plus 4 is 4. 4 times 4 is 16. This is 1. So 4 plus 4 16. So negative 1 over 16 is the final answer. Okay. So here part E, x going to positive infinity. So basically we are finding the horizontal asymptote on the right side. X is approaching to infinity, positive infinity. X is very big, but positive big. Okay. So in this case we need to divide the top and the bottom by the highest exponent of x from the bottom. So highest exponent x to the 5th. So divide top and bottom by x to the 5th. Limit x going to infinity. So divide top means we need to divide each term by x to the 5th and divide each term by x to the 5th. Okay. So dividing by x to the 5th, 3x to the 5th divided by x to the 5th, just 3, plus 5x over x to the 5th. So basically 5x over x to the 5th, 1 copy cancel, so 5 over x to the 4th, and plus 2 over x to the 5th. Similarly 2 minus, we have negative 2x cube over x to the 5th, 3 copies cancel, just 2 copies left, negative 2 over x squared plus 1 over x to the 5th. Okay, now we take the limit, and this is just what we did on the top and bottom. When x goes to infinity, 5 over this will be 0, this will be 0, because the bottom is going to be very big. Same thing here. Then what is left? 3 halves, and there are no more x's left, so 3 halves is the final answer.